Hello there, this is part 3. I'm going to do this example. Okay, so I'm going to do condition number 1. Given that the cutting speed is 196 meters per minute, undeformed chip thickness 0.094, width of cut 6.35, cutting ratio is 0.37, rake angle is 10, and these are the measured values. Okay, 9.654, and the cutting ratio is also measured. So we're gonna calculate the normal and shear forces acting on the tool first. So this is part A. We're going to proceed by we're going to determine the normal and shear stresses acting on the shear plane, and C, we're going to construct merchant circles based on these numbers. Okay, so let's do part A. So to do part A, what we know is FP. Okay, we know that FP is equal to 1463. Likewise, you know FQ, and it's equal to 965 Newton. And we are also aware that alpha is equal to 10 degrees positive. Okay, so plus 10. So from here, these are the formulas that I've taken. So we're going to find what is FC. So given the formula, not given in the exam, you have to derive this formula. Okay, so FC is equal to FP sine alpha plus by FQ, okay, cos alpha. Okay, so it's a matter of plotting the formula. So you got 1463 sine 10 degrees plus by 965 cos of 10 degrees. Okay, so this will be equal to 1463 sine 10 plus by 965 cos 10. So this will be 1204. Okay, 1204 Newton. Let me do it again. So 1463 sine 10 plus by 965 cos 10. So this is equal to 1204. Then you can calculate NC. So NC is equal to FP cos alpha minus by FQ sine alpha. So FP we are given to 1463. Now it's cos 10 minus by 965. Now it becomes sine of 10. So this will be equal to 1463 cos 10 minus 965 sine 10. So I'm reading at 1273 Newton. Okay, 1273 Newton. So let me do it again. 1463 cos 10 minus 965 sine 10 is equal to, oh, I think I made an error. Let me do it. 63 cos 10 minus 965 sine 10 is equal to 1273. I think I did it correct before. Probably I pressed the calculator wrongly. Okay, Newton. Yep, 1273. So that is the first part. Really straightforward, isn't it? Okay, but you have to, you don't memorize the formula. It's so easy to derive. Just derive it. Okay, but I did not want to derive it because I want to show you how to plug in the numbers quickly. So part B, right? Part B, you have to find the determine the normal and shear stresses acting on the shear plane. So you're going to use these formulas F, S, and NS, but you have to find the shear angle first, right? We have to find the shear angle, and we derived earlier that we know that tangent pi is equal to R cos alpha divided by 1 minus R sine alpha. Okay, so on this context, you know that R, okay, given down here, you can see R is equal to 0.37. So you have 0.37 cos positive 10 degrees, and you divide by 1 minus 0.37 sine, okay, positive by 10 degrees. So once you do this, so 0.37 cos 10 divide by 1 minus 0.37 sine 10 close bracket, so you get 0.389, and then you inverse tangent pi, okay, you get 21.3 degrees or 21.5. okay. I'm going to call my 21.3 degrees. So from here you can calculate the area of the shear plane. Let's not calculate the area of the shear plane first. Let's do some simple calculation to calculate our Fs and Ns. Okay, so Fs we know. We have to calculate the shear angle because the formula we are going to use is related to the shear angle. So this will be equal to Fs, okay, which is parallel to the shear plane, is equal to Fp cos pi minus by Fq sine pi. So your Fp, so Fp is 1463 cos of 21.3 minus by Fq, which is 965 sine of 21.3. okay, so this will be equal to 1463 cos 21.3 minus 965 sine 21.3. so this will be equal to 1012.5. okay, 1012 is enough. Okay, 10, or because it's 0.5, it's 1013 Newton. Let me do it again. 1463 cos 21.3 minus 965 sine 21.3 is equal to 1013. So you can find what is your Ns also. So Ns is Fp sine pi, and then you have plus by Fq cos pi. Okay, so this will be equal to 1463 sine 21.3 plus by Fq 965 cos of 21.3. okay, so 1463 sine 21.3 plus by 965 cos 21.3, so it's equal to 1431 Newton. Let me do it again. 1463 sine 21.3 plus by 965 cos 21.3, 1431. okay, so these are your values. So you have to find the area of the shear plane. Because you're going to find stresses on the shear plane, so you have to find the area of the shear plane, which is AS is equal to T omega over sine by the shear angle, where T is the undeformed cheek thickness. We know down here is equal to 0.094, so it's equal to 0.094 times 10 to the power minus 3. You have to convert everything to meters here. And then the width of cut, if I'm not wrong, is 6.35 times 10 to the power minus 3. Everything is in meters. 6.35 times 10 to the power minus 3, and then the whole thing you divide by sine 21.3. okay, so from here, so 0.094 power minus 3 times 6.35 power minus 3 divided by sine of 21.3. so the area that I've got is 1.6432 times 10 to the power minus 6, okay, times 10 to the power minus 6 meter squared. Okay, let me do it again. 94 power minus 3 times 6.35 power minus 3 equal to divided by sine 21.3 equal to 1.64. so you can calculate the stresses acting on the shear plane. Okay, so normal stresses, acting on the shear plane. Okay, so normal stress. So this is equal to force divided by area of the shear plane. Okay, so NS is equal to 1413, or let's say 1431, divided by 1.6432 times 10 to the power minus 6. So this will be equal to 1431, or 31 divided by 1.6432 power minus 6. So this will be equal to 870. 0.862 times 10 to the power 6 Pascal. So this is the normal stress acting on the shear plane, and then you can have shear stress acting on the shear plane, so it can be tau is equal to Fs over As. So Fs is 1031 divided by the area 1.6432. Okay, so 1031 divided by 1.6432 power minus 6. So this is equal to 627.434 times 10 to the power 6 Pascal. And it's normal that the normal stress is higher than the shear stress. So the next thing I want to do is I want to construct Mohs circle. Sorry, not Mohs circle. What am I talking about? Merchant circle. Okay. So I'm going to use a scale. Okay, that can show you guys how to do all this on merchant circle. Okay, so on merchant circle, okay, I'm going to move this. This is your homework, or this is a question that you have to do later on. Okay, so I'm going to draw. I'm going to schematically draw a merchant circle for you. Okay, so the first thing you have to find, so construct merchant circle. Okay, construct merchant circle. Okay, merchant circle. So what we know is I'm going to set one box or one square. You have to set your scale first. So scale. Okay, scale is 1 square. For me, I use 1 square. Okay, you can use 1 centimeter. Okay, I can't. This is software that I can't do it. Is equal to 50 Newton. We find that our shear angle is equal to 21.3 degrees. Right. We know that FP is equal to 1463 Newton. And we know that FQ is equal to 965. Okay, so I'm going to sketch. Okay, I'm going to sketch. You can draw with your ruler. You can set. So I'm going to draw my FQ. Okay, so 100, 200, 300, 400, 5, 6, 7, 8, 9, and 9. Okay, I'm going to change. Okay, maybe 1 square, 100 Newton. Sorry about that. Too big. Okay, so that will be less than 10 squares. So 2, 4, 6, 8, 9, 965, somewhere around here. So this is your FQ9. Then it's 14.63 on FP. Okay, so I'm going to construct 2, 4, 6, 8, 10, 12, 14, 14.6, somewhere around here. So from here, what I realized that, so this is your FP. Yeah, this is your FP, right? FP line, and this is your FQ line. Then from here you can find your resultant. Okay, your resultant is also equivalent to your diameter of your circle. So this is the resultant from here to here. This is a resultant. Okay, so this is your resultant. Okay, so then I'm going to sketch out the positive right angle too. So we're going to have a positive right angle too, and the right angle too. So this is my. So we know that this is your R. Right, we know that. Then I'm going to construct my positive right angle 10 degrees. So this is the cutting edge. This is my datum, and then I'm going to draw 10 degrees positive. Okay, so I'm using my protractor now. So 10 degrees positive will be somewhere around here. Okay, so that's my 10 degrees line. So this is in fact the rake face. Okay, so I'm drawing the rake face, sketching the rake face, and then we have our clearance face, and this is our 2, so you know where we are looking at. So that's our 2. Okay, and then from here we can construct our circle. Okay, so I'm going to try sketch out our circle. So I'm going to sketch out. So I calculated the resultant. So 2, 4, 6, 8, 10, 12, 14, 16, 17. I calculate my resultant 0.5. Okay, so I'm going to stretch this to 2, 4, 6, 8. You don't need to do this because you have a compass. Your compass, you can draw your circle. 2, 4, 6, 8, and a bit out, and a bit out. Okay, so this is my circle. I'm trying to fit everything in. Happy medium. So this is my happy medium now. Okay, so that is the circle that you can draw. Then you can now construct your FC line. Okay, so you can construct your FC line. Okay, so this is your FC line, and then you can construct your NC line. Okay, so this is going to be your FC line, your NC line. Okay, then you know that the shear angle is 21.5 or 21.3. It's impossible to draw 0.3, so I'm going to roughly eyeball this. So this is about, okay, oh sorry, so this is about 21. Okay, so this is about 21 degrees. So I'm going to draw another line. So this will be your FS, and then this will be your NS. Yeah, that will be your. Okay, and in terms of, you will be wondering, hey, if you draw this out, okay, your FC and NC, right? So I'm going to look at my FC and NC values. So your FC and NC value. So NC 1273 and 1204. So your NC will be 1273. Okay, NC will be 1273, and your FC will be 1204. Okay, so you can see from here the length is about the same. Okay, the length is approximately, I mean NC should be slightly longer if I draw it to scale properly, and FS will be 1013. FS will be 10, which is shorter than your NS, and the NS we calculated is 1431, which is true, significant longer. Okay, NS is your 1431, and this angle over here is your 21.5 or 21.3. I have to draw 21.5 because there's no way I can do 21.3. So I'm going to stop here now. Okay, I mean stop here for this section. So you have to do this question. You have to try to attempt this question. So this question, I want you all to do condition number 2. Okay, condition number 2. That you have to draw merchant circle based on scale 1 cm 200 Newton. Determine normal stress and shear stresses and the normal force and shear stresses acting on the tool. You can calculate or can do it geometrically, fine. Okay, so the due date is 26th of November at 2359. Okay, so I'll come back again. Okay, we're not done yet, and we're going to do merchant's model.